So if you need a gigabit Ethernet or a 10 gigabit Ethernet, that's a lot different than if you need T1 or N by T1 like speeds. So the first kind of decision point is what's the bandwidth requirement of the service that's being delivered to the customer's premise, okay? Higher bandwidth, obviously at some stage you're going to kind of cross the boundary where you need fiber-based access. There's kind of a middle ground where certain copper technologies or fixed microwave, fixed wireless services can serve, and I'll go into a little more detail on that in a minute. And then at the lower speed, copper-based access is appropriate from a cost perspective and a pervasiveness perspective. And I guess that's the second determining factor. Where is the customer's location? What's their bandwidth requirement? Okay, and then what's their location vis-a-vis our facilities, our network, okay? At some stage, they're going to get onto fiber optic networks of XO. The traffic's going to be pulled back to a switching center, a POP, okay? And then maybe it won't go any further, or maybe it will, depending on the nature of the service. So back to the access technologies or methodologies that we use. For lower speed access, typically it's copper-based. That can be as simple as a T1 service all the way to the customer prem. That's appropriate for their CPE. As we mentioned earlier, in an increasing sort of way, attachments to our services are some speed of Ethernet delivered over some type of physical layer technology, okay? So the way we think about it is not our installed base, which has got tens and thousands of attachments and ports and so forth of services, primarily in the TDM hierarchy. But for new installs, for IPVPN or DIA service or VoIP-based services, we can see an increasing fraction of those new services being achieved across Ethernet attachment circuits of the appropriate speed. So let's go through the speed hierarchy for Ethernet, okay? Starting at the low end, we like, best of all, Ethernet over copper. So what does that mean? Ethernet over copper is essentially striping Ethernet frames over one or more unbundled copper pair that comes from the ILEC copper plant. Nothing is more pervasive than this plant itself, okay? It's used to implement things like T1s today. It can be used to implement Ethernet over copper, which XO is a leader in, we think, in the United States, and an early adopter as well. We're very enthusiastic about Ethernet over copper fundamentally because the cost to us of leasing dry copper pairs without any electronics on them is quite low. You can't get any lower in that space, one could say. You can take these pairs and terminate them in the appropriate customer premise equipment, and then in our co-location sites that we maintain in Bell End offices around the nation, we have concentration equipment, okay, that terminate the other end of the copper pairs. For a given service, whether it's as low as 1 megabit per second or 3 megabits per second or 5 megabits per second or 10 megabits per second, on up to 20 megabits per second in some instances, we'll adjust the number of copper pairs that are ganged together or inverse multiplex together in order to achieve this high quality symmetric Ethernet attachment circuit. Again, over copper we call it, but it's fundamentally over these unbundled pairs. That works great within our footprint for this technology, which is, again, determined where our co-location sites are in a certain radius or wire length out from those co-location sites, okay? Nothing has better cost properties in this bandwidth regime than Ethernet over copper. So if I've spent a lot of time on Ethernet over copper, there's a reason, because we're big fans of it. We'd like to continue to push it. We think there's some successor technologies coming in the underlying physical layer of Ethernet over copper, where we'll get even better bandwidth. And again, the bandwidth is just like DSL technologies, dependent on the wire length, okay? But things like introducing asymmetry and things like this could very well be part of the future of Ethernet over copper services.